Hi, in this video we're going to talk about stacks in Python and what a stack is. Take for example you have a stack of books, okay? And you want to get to the bottom book. Well, in order to do that, you've got to take all the items off the top one at a time. And I'm not talking about reaching over and grabbing the bottom one and sliding it out or anything. You have to take the top ones off. It's called last in, first out. You keep putting books on top, and then when you want a book, you got to take one off in order to get to the next one. So that's what a stack is, and it's used a lot in programming. That's what we're going to do now is we're going to go ahead and create a stack and then do a test program on that, and then do a couple of example programs that we can use on solving a problem here and there. So in a stack, what we're going to use is a list as the underlying structure for the stack, and then we're going to pick out the methods for a list that will be used in order to process the stack itself. So I'm going to go ahead and open up a new file, and we'll get started on creating our stack class. So in here, what we're going to do, we're going to need our init. Okay. And then what we're going to do is initialize our list that we're going to be holding the data in here for the stack. So our self.items is going to be equal to an empty list. Okay. One of the things we're going to want to be able to do with our stack is check to see if it's empty or not. So all we have to do on this is return self.items. If that is equal to bracket n bracket, that's an empty stack, so we would return true. We need to be able to get an item onto the stack, and they call that a push. And we need to pass in the item that we're going to be using to store in there, and then it's just a self.items.append, and then the item that we want to put in there. Now, the reason that we use append on here is because when you add to the end of a stack, nothing, or to the end of a list, nothing in there has to be adjusted. So this has a big O notation of O1. So it's constant. No matter how many items you put in there, every time you do this, it only affects that one item. Okay, the other thing we need to do is be able to remove an item from the stack. And to do that, what we're going to use is a pop. Same thing. We need to add it and remove from the same end of the list. So if we do this at the end of the list, append and pop are both O1s. So that's the best scenario for this. So all we have to do here is return self.items.pop. That'll return the item so we have it if we needed to do some processing with that. We also want to be able to look at the last item that's on the list, or in the list for our stack. So we'll just do a peek. We'll just look at this. So we're going to return self.items, the length of self.items, oh, wait a minute, should be length, yeah, that's right, parentheses, -1. Oops, wrong parentheses there. There we go. Okay, so what this is going to do is going to take the length of self.items. Remember that the length is always one more than the number of items that are in there because it starts with 0. And so we subtract 1 off to get the index of the last item in there. And then the last thing is we want to return the size. There may be times when you want to know how many items are in the stack. Okay, so we just return the length of self.items. So that's our stack. I'm going to go ahead and get that saved. And got a folder here that I'm going to put this in. Okay, so I got that saved in there, and so that's going to be the stack that we're going to use in our um, in this demonstration that we're working on. So the next thing I want to be able to do is we're just going to do some testing on this to make sure that it works. Okay, so I'm going to import my stack. I'm going to do it this way. I'm going to do a from stack import. That way I don't have to use the word stack on the front of everything that I do in here. Okay, so in here then we're going to do s equals stack. I'm going to do a lot of print statements in here so we can see what's going on. Is s empty? Okay. I'm going to add some items to the stack, so I'm going to do an add 4 to stack. And then that's going to be an s.push, the number 4. I'm going to add, oops. We're going to add dog to the stack. That's going to be an s dot, and then the string dog. So after 2 pushes, what's on top? So we're going to do an s.peek to see what's on top of this. We're going to add the word true to the stack. So after that other one, we're going to see what the size is on this at this particular time. We're then going to check to see if our stack is empty. Then we're going to add 8.4 to the stack. And then we're going to do 3 more prints here. We're going to print out the last item. Another pop. And then check the size again. Okay, so that's all the checking we're going to do on this. Call main, get this one saved. This one I'm just going to call stack test. .py. See if I got any errors in here. I've been typing pretty fast. Nope, everything seemed to work. The stack is empty, so it's true. We added 4 to the stack. We added dog to the stack. After 2 pushes, what's on top is dog. We added true to the stack. After another push, how many is in the stack is 3. Check if S is empty, it's false. We add 8.4 to the stack. We pop the last item, which is 8.4. Another pop is true. The size is now 2. So everything seemed to work really good on that. So what we're going to do now is actually do a program that will use the stack to solve a problem. We want to check if a set of parentheses are balanced. So in order to have a balanced set of parentheses, for every opening parentheses, there has to be a closed parentheses, and you can't have any left over at the end. So I'm going to go ahead and open a new file here. I'm going to use the stack. I'm going to close this one off because I don't need it anymore. I'm going to leave the stack in here because I don't know if I might need that. We tested everything out, so there shouldn't be any errors on it anymore. So we'll see. Okay, so from stack, import stack. I'm going to do a parentheses checker, PAR checker, passing in a symbol. So S is going to be equal to my stack. Use a Boolean variable balance. It's going to be set at true to start with. And we're going to set an index equal to 0 as we go through the symbol string that we have there. So while index is less than the length of my symbol, and we're still balanced, we'll go in here and process. Okay, I need to change this because I was going to use symbol down there. Change this to symbol string. So symbol is equal to symbol string index. I'm going to pull the first item out of there. So if our symbol that we just got equals an opening parentheses, then we're going to push that onto the stack. Else, if s dot is empty, meaning we don't have a symbol to pull off, but we did have an opening one, so then our balance is going to be false at that point. Else, we then would pop it onto the stack, or pop the other one that we have, the closing parentheses off the stack because that matched up. Okay, so we come out here, index plus equals 1, and then when we get done with the while loop, if balanced, and s dot is empty, will return true. Else will return false. Okay. So it's checking here at the symbol. We're going to get the symbol. If it's an opening parentheses, then we push it onto the stack. Okay. If it's not opening, then it's got to be a closing, unless we're not checking for errors that we put the wrong stuff in there. So that means it's a closing one. If the stack is empty, that means we had no opening one to match, so our balance is false. Else, if it's a closing one, and so we pop that one off the stack and get ready for the next one to work with. Then we increase our index. Okay. Once we get completely done, if balanced is still true and our stack is empty, then it was balanced. Otherwise, it wasn't. So let me get this saved. And save it as PIR checker 1.py because I've got another one that we're going to do with this one also. And then let's run this. And main, I must have, oh, I didn't put main in here. How about that? Sorry about that. Going to be kind of hard to test something if we don't have anything to test. So I'm going to print. I'm going to do an opening, opening, close, close. Okay, that's what we're going to check. So we're going to do opening, opening, close, close. Okay, and then we're going to do on this one, we're going to do an open, open, close. You know that one's not going to work, but just open, open, close. Okay, so now, whoops, don't need that many in there. Here we go. Let's run this and see, since I got one in there now to run. And there we go. The first one was true and the second one was false. So it worked. Okay. Now we're going to do a little change to this. I'm going to use the same one and hopefully I can do the modifications okay in here and it will help. Won't have as much to type on here. What if we have to use different symbols in here? What if we need to use, in our math problem, we're going to have curly braces, we're going to have brackets. So we want to check on all that. Well, we can't just look for the parentheses, then we got to look for the other stuff too. So most of this is going to be the same. I'm going to leave this as a parameter checker. I'll save it as 2 when I get done here. Create our stack, balanced equals true, index equals 0. So while index is less than the length of our symbol string and balanced, symbol equals symbol string index, so we get pick one up. So if symbol is equal to, now it's going to be equal to one of 3 things. Either an opening parentheses, an opening bracket, or an opening curly brace. Okay. So if it's one of those 3, we're going to push it onto the stack. Else, if our stack is empty, then balanced is equal to false. Else, what we're going to do is we're going to call a helper in here in a second. Top is going to be equal to s.pop. And so we're going to pop the top one off. And then we're going to check to see. If not, we're going to call our helper function matches. We're going to pass in top and symbol. Then balanced equals false. So if they don't match, it's going to be false. And that's all we need to do there because we already popped off the other one on there. Okay, so an index plus equals 1. We check to see if balanced and s dot is empty, return true, else return false. So that's all we needed to do is add that little bit in there so we could check that out. Now we just need to add in our matches. And the book, I think, uses open and close, which are reserved, not reserved, but they're reserved with files. So I changed it to opened and closed so that it doesn't use words that are already in libraries that could be used in there. I use opens here, equals a parentheses, open bracket, open curly brace, and closes equals closing parentheses, closing bracket, closing curly brace. And these have to be in the same order or it won't work. So we're going to return opens dot index open. So we'll get the match up the index on that. Equals closes dot index closed. So if those two, if they're in the same location and those two match up, then it'll return true, otherwise it will return false. Now in our main, we want to change that a little bit so we can test this out a little bit here. We can do this a little bit different and I'll fix those there. I'm going to do symbol SYM equals bracket, parentheses, curly brace, end curly brace, end curly brace, the right key there, there we go, end parentheses, open, close parentheses with no space, open, close parentheses, end bracket on there, and then I'm going to copy this here, replace this down here with that, take out that, don't want that in there, and then do parameter checking, and then put all that stuff in there. I'm going to take this one out. We're just going to check for the true part on this one. So, okay. So let's see if I got everything in there correctly. Run. And it says check is false. Parentheses, parentheses, it should be true. Bracket, parentheses, those two close, that closes that one. That opens and closes is good, and that's that one. I don't think I put any spaces in there. Just double check it and make sure that there aren't spaces. I don't think there are. No. Okay, so I need to double check all my stuff up here. Parentheses, bracket, curly brace, parentheses, bracket, curly brace. Go up here and check this stuff. If symbol equals this, s dot push symbol, else. If is empty, balanced equals false, else. Top equals s dot pop. And if not balanced, if not matches top symbol, balanced equals false. Index plus equals 1. If balanced and is got everything in here, and I think it's everything's lined up correctly. Opened, closed. Opens dot index opened equal closes dot index closed. I don't understand on this one why. I've got to have one thing missing on there. Okay, so this one over here was when I was going after. So you can kind of look at this with yours and see if it matched up with mine. I've got one thing off just a little bit someplace in here for it to come up with the false. Get these matched up a little bit more closer here. Okay, balanced equals true, index equals 0. Well, index is less than the length, and balanced. Symbol, if symbol in those three, s dot push symbol, else. Balanced, else. S dot pop, if not matches top symbol, balanced equals false, index plus equals 1. If balanced and return true, else return false. Down here, make sure I didn't get anything messed up in it. Opens. Those all three are right. Opens, index, opened, equal, closes, index closed. Oh, there it is. I found the error. These should be brackets, not parentheses. On one of them. Maybe I have. This is the one here. There should be parentheses and not brackets. That's what it is. One of the other aren't here, so I'll get these fixed. There we go. Very difficult sometimes to see these. Okay, it was this one here. Nope, that wasn't the error because the brackets don't work. So I must have had them right to begin with on there. But anyway, I don't know exactly what the error is on there, but I showed you the correct one and it looked exactly the same to me on there. So um, anyway, I'm going to stick with this one, but you get the idea of how this works. I'll have some other examples here that we'll look at on these and then we'll get into cues. So thanks a lot. Bye.